New man in the field, works from dark to dark. I lay down in the shade, nobody saw me part. Got the disempowerment blues, nothing left for me to do. Got the disempowerment blues, got replaced and the blues did too. Hand me a dollar, say stay off the street. Tip my hat real polite, can't taste it when I eat. World got fast, I got slow. Let go the wheel, car still go. Got the disempowerment blues, nothing left for me to do. Got the disempowerment blues, got replaced and the blues did too. Crossroads, I went to sell my soul. Devil just shrugged, said somebody took the road. Got the disempowerment blues, ain't no use, ain't no use. Got the disempowerment blues, wrote this song, but the song's used too. That's alright. New man in the field, works from dark to dark. I lay down in the shade, nobody saw me part. Got the disempowerment blues, nothing left for me to do. Got the disempowerment blues, got replaced and the blues did too. Hand me a dollar, say stay off the street. Tip my hat real polite, can't taste it when I eat. World got fast, I got slow. Let go the wheel, car still go. Got the disempowerment blues, nothing left for me to do. Got the disempowerment blues, got replaced and the blues did too. Somebody came down at the crossroads. I went to sell my soul. Devil just shrugged, said somebody took the road. Got the disempowerment blues. Ain't no use, ain't no use. Got the disempowerment blues. Wrote this song, but the song's used too. That's alright.
Get on screen.
Twitter may or may not be down. It's not loading for me on a couple different URLs.
Twitter. Okay.
It seems like, I don't know, it seems like it is working, I guess.
Yeah, we are. It's 1, it's 2, that's the 3. And
all right,
so good morning. It is Thursday, July 7th, 2026, and welcome to Fable Day.
We're back, baby. Both live here on AI in the AM and with our favorite America's top model to clean things up, clean up all the messes that we've made with lesser intelligences over the last couple weeks. So very glad for that.
I remember we had some bets. It was before July 1st. I thought it would be before 4th of July, definitely. And so it was on July 1st, basically. We got the model on July 1st. We got the announcement on the 30th of June. So.
Yeah, I originally set the over-under for the Friday before, so it was definitely the over relative to my guess. Not a crazy amount of time. I think the sort of Sam Altman public statement of like, it's not crazy for the government to want to take a look at these things for a couple weeks before they go live is true. And if we can get into a sane regime and a reasonable cadence, and this can be kind of part of the pre-release process, it does feel like there's still some chance for it to be all to the good. And I do appreciate that folks are at least, waking up and starting to take this stuff more seriously. A lot of open questions still about this, including like generally what the hell happened, right? I mean, we're still kind of piecing it all together through reporting and hearsay and, what exactly was it that caused this in the first place? Was it really Amazon that called the government in a panic? If so, like why? And, were they confused about what was going on? That would be weird. Were they, is there some sort of weird intrigue between Amazon and Anthropic? Amazon has a big share of Anthropic. And as big as Amazon is, that share of Anthropic is starting to become pretty material to their overall market cap too. So, it would be strange for this to be some sort of sabotage, but there's not really I have a hard time telling a story that doesn't leave me with weird open-ended questions around what was seen, why was it reported in this way, how did we end up in this sort of panic situation, and then how was it fixed? The best information I've seen suggests that the way that they mostly reassured the government was to painstakingly point out that the things that were observed had already been capabilities that were in the wild with other models for some time. And again, that's a sort of strange way to get back into the, the approved column, is to say, look, everybody else, it's kind of like, something my kid would try, right? Like, he was doing it too. It's a sort of a strange way to try to get out of the frontier model penalty box. So yeah, I mean, if you fill in all the gaps in a charitable way, you can tell a Judd Rosenblatt type story where this is, kind of a clumsy perhaps, but ultimately enlightened step to take for the government. Or if you fill in those gaps in an uncharitable way, you're just kind of left shaking your head and thinking, who's making these weird moves and causing these weird hiccups? And I would love to see better information at a minimum. At this point, it really seems like the conversation can and should be more public than it has been. So that's what I'll be watching next in between prompting Fable. Do you have any thoughts on where we are at this point? There's also the question of how nuked it is coming back or nerfed. And there I don't have enough information yet to really render a good judgment. For my personal use, it does not seem to have been affected so much that I can't do what I want to do. But then I have seen at least some reporting online suggesting that the fallbacks to Fable are more, or the fallbacks to Opus are more frequent, and that on some, coding benchmarks, terminal style benchmarks, the performance overall is worse because of those higher rates of fallback. What do you make of it at this point?
So in my testing, the fallback rates were lower than before.
Interesting.
And it primarily because I was dealing with the production database, etc. And the Fable before, the moment you mentioned the word production, it's out. And now the Fable now is happy to address production databases, etc. So I think actually what ended up happening is that they had a sit down and they refined. They actually got their classifiers looser for a lot of things. And I've also seen online people say that they have, when they get dropped out for cybersecurity research, they can appeal. And the company does a quick, like, why do you need this access? And then they have provided access. So there's some kind of so I think the defense in depth concept of, hey, we're going to have classifiers, and then after that, we're going to have permissions for certain people, has basically been accepted by the government. And I think that's where we are for Fable. People are still saying that capability is very significant. It's a significant upgrade. It's very hard to judge these things at this point, so we will see. GPT 5.6 is coming out today, I hear, 2:15 today, so 2:15 Pacific time today. And I think the OpenAI guys are saying GPT 5.6 Soul Ultra. That version, I think they are standing behind as better than Fable. But it just shows you how is anyone not part of this kind of AI bubble supposed to know which model to choose? GPT 5.6 Soul Ultra. It's just the versioning is just so obtuse at this point.
I think the fact that they have dialed in, and again, we're inferring this from, limited data points, but it matches my expectations that even a 2-week break and the 5 days of, was it even 5 days? The 3 days of data that they were able to get on initial usage would be enough for them to meaningfully dial in the precision of various defense in depth safeguards. Mm-hmm. And we've talked about this a couple of times, right? Just how just in time all this stuff is. I wouldn't be surprised if obviously they've been working on these safeguards and iterating on them for some time. So it's not like the whole program is new, but the iteration cycle is pretty fast. So this 2 weeks, if you kind of map back 2 weeks before they actually launched Fable and where they were then and how much progress they made, in the immediate run up to the first launch, I think it does just go to show that so much of this stuff is really just in time and fundamentally super iterative. And yeah, I guess I continue to be of kind of two minds on everything. I do think iterative deployment has served us pretty well so far. If I, critique the OpenAI strategy at a high level, I would say that's one of the things it feels to me like they have gotten quite right. And more so than Anthropic, right? I mean, this is one way Anthropic has kind of converged on the OpenAI paradigm. Initially, their whole thing was much more conservative around deployment. There was at one point they were broadly understood to have made some sort of commitment to never advance the frontier. Obviously, that they'll say now that they never actually said that. I'm pretty sure that it was understood. It was meant to be understood. But regardless of exactly how firm their commitment was to that, clearly they're doing it now. And clearly they've bought into the OpenAI iterative deployment is kind of the best path to things going well broadly. So I think that still makes sense. But you do wonder, I mean, all these models kind of start to come under some strain as you get to sufficiently powerful capabilities or regimes where a small enough gap in the defenses is enough to create a huge problem. And yeah, it feels like in multiple ways, we're kind of riding these paradigms that have worked well so far, and we just don't know if and when they might break. And if they do break, they might be breaking at kind of critical times, which is a strange juxtaposition on multiple different levels. People talk about that all the time, of course, with alignment, but I think it extends to these defense in-depth safeguards. And at the highest level, it kind of extends to the whole iterative deployment model. So as always, confusing, but selfishly, I'm glad to have it back. That's for sure. And I am excited to check out 5.6 as well. I feel like it's probably going to be, for multiple reasons. One, obviously, they're going to start charging. We'll see. I mean, I kind of expect it's going to be interesting to watch Anthropic dance around limits and usage, because OpenAI is going to offer a ton more tokens, it seems, with 5.6 at their $200 price point than Anthropic is going to be offering for Fable with their $200 price point. As of now, from what we have seen with the relaunch, it goes until July 7 on this preview access basis, and then you have to pay the API rates. And that's going to be order of magnitude, maybe more than an order of magnitude more expensive than 5.6 tokens if you have the pro subscription. So it's going to be interesting to watch how they manage that. I would bet that Fable comes back to the Claude Max subscription. It seems just very hard for them to have no Fable there. That would make ChatGPT Pro, I think, just a better product for a lot of people.
Yeah.
And I don't think they want that. So I think they're going to want to have some access to their top model in that bundle. Mm-hmm. But it'll depend on how they've obviously got their limits, and they've got to destroy demand to clear their own market. And so it might depend on just how strong demand is. I do think people, as we discussed in the interim, I think people will be willing to pay the API rate, because things like the Frontier code success rate and what that implies around just general taste and quality of work, judgment, quality of writing, which I've seen too, to pay a little less than 2x for that much improvement, I think is going to be worth it to a lot of people. But in the meantime, then we'll also all be kind of going the direction of like, how do we create our own little neutral platform for ourselves that does the model routing in just the right way? And is this something that people will be outsourcing to providers? Will we be going to like Sakana and having them handle the routing? Will we be just like plugging into Open Router? Will we just kind of keep it to a couple core subscriptions and have Fable decide when to send it over to Codex? That's, I think, going to be a definite area of exploration for a ton of people. And I'm already doing a little bit of that just yesterday and today, because, my kind of default assumption is I'm going to spend $1,000 a month on AI tools. And yet, if I, don't do any optimization, I could blow past that real quick with, if I just used Fable for everything. So it's going to be, even as somebody who has a plan to spend $1,000 a month without even, thinking twice about it, even there, it's going to start to, that's going to kind of force me to do some thinking about how do I want to allocate these tokens and when can I use Codex. It'll be really interesting to see if 5.6 is better at the sort of general purpose knowledge work too. That's the other huge thing. It's clearly going to be good at coding. It's probably going to be best at math. It's probably going to be the most steerable for coding. The vibe check I get is that if you really know what you want coded and you spell it out in great detail, Codex is probably a bit better, better at the instruction following, just a little more reliable to do exactly what you told it to do. Whereas if you don't know what you're doing and you're just kind of vibing it, then Fable's probably better. Will this 5.6 though start to catch up on some of these softer skills, kind of theory of mind, for when you don't explicitly say everything that you want? Or will it continue to be sort of this more autist, very literal minded assistant that struggles more to fill in the gaps? I'll definitely be watching that and trying some things. This is the first one in a while where I felt like, they've sent some signals that maybe it could have a different kind of character. And I'll be really interested to see, can it help me with writing? Can it do a good job on intro essays for the podcast?
Yeah.
Claude has had the top spot on that for all but like a week out of the last few years. There was one moment where Gemini 3 took the lead in the Write As Me test that I always run. GPT has never had the lead. Claude has almost always had the lead, but I'll definitely be interested to try it again.
I wonder if there's a big difference between giving it as reference your writing before any AI and your writing post AI help. I wonder if there's a significant difference between the two.
Well, probably not too much for me. I mean, that is something I think for people to watch in general. I've continued pretty much to rewrite everything Claude has given me out of some sort of masochistic commitment to, full authorship. And really haven't compromised on that much. As we talked about, in the first days of Fable launch, I do think now's the time to start to rethink some of those commitments. But I think now will be the dividing line for me, at least, where the co-authorship might mean that there is like a meaningfully different input to, as part of the prompt in the future. Thus far, I'd say all my kind of historical stuff is mostly still, I can kind of claim enough authorship that I wouldn't worry about that too much. I should try Pangram Labs on myself. That would be interesting and pretty easy to run test. Like if I just took all my intro essays through history of the podcast and plotted their Pangram Labs score over time, would I see a drop off in my human number as I potentially lean more and more on Claude than I even realized I was? It's certainly a possibility, but I'd bet against it. I would bet that I still get like 100% human on pretty much everything up through present. But that could be something we can, report back on in our next live session. I do like sitting here sometimes and just riffing on ideas that we can then vibe code and actually bring receipts on rather than purely speculate.
I have, you know, I do see a lot of people trying to go down the model routing route in the sense of let's start to use open source models. And there was a little interview with Alex Karp of Palantir yesterday, where he just goes ballistic on frontier model companies, saying that they're going to come in and they're going to steal your data and they're going to steal your business and they're going to steal your IP and you're going to have nothing left. And that this is unacceptable and we should all be using open source models. The really funny thing is, right after that, Clement Delenge, who is the CEO and founder of Hugging Face, then responded with, well, Palantir is a free member on Hugging Face. Doesn't have a subscribed, not subscribed as a business. And so why don't you actually put some money towards open source? If you're so keen on open source, why don't you put some money into it? And I think that basically describes all of most of US tech firms are in that position where they don't like the frontier labs, but they don't really want to use open source either. And they're not supportive of open source anyway. They kind of want to use open source if it's free and they don't have to do anything. But if they have to do anything at all by themselves, they prefer to use a closed source and just pay for it. Or use a SaaS product. So I also believe the frontier model companies can model route at any time internally. So again, they're playing this kind of revenue maximization game where they decide to route internally depending on whether they think that there's enough revenue there or not. And so if they say, okay, there's $100 million at a 30% discount, can we serve that $100 million worth of revenue, not using our, let's say, Fable, but let's say using Sonnet 5? And how would we structure that so that we could hit the capability that is required and also hit the cost? And so the Frontier Lab can always do this kind of advisor strategies where you have Sonnet 5 as the core model, which then pulls in Fable as an advisor for various tasks. And in fact, on the API, that is actually what the product team at Anthropic has been promoting. They've been promoting to people, if you're going to use Sonnet and Haiku, use Sonnet and Haiku in your kind of classification systems for your customer service. But when things get too difficult, pull in a Fable. And so this is basically model routing, but model routing driven by the enterprise customer themselves, teaching them how to model route effectively using a smaller model. But you can also model route using a better model, and that is part of this kind of split tasks into to-do lists and then send out independent agents. Some people have been on Fable right now in Claude Code. If you set it to Ultra Code right now, you actually get this experience. But Fable doesn't use sub agents, or you don't know whether they're using sub agents which are of lower models. They won't tell you. But you can explicitly ask Fable to use Sonnet sub agents, and it will use those Sonnet sub agents and check their work. And so you can start streaming a lot of this work actually to other agents, even using the existing model, and then cut down. I hit my Fable limit yesterday, the 5-hour limit. I hit my Fable limit, and I went online and I saw one of the other software engineers, influencers online, and he said he had done 16 pull requests since Fable was out, hadn't hit his limit at all. But he had a structured strategy of, he'd already told Claude, these are the models that you can use. You have a Fable, you have this, you have GPT 5.5, which is available to you by command line as a MCP tool. And he basically told it, and it also told it, this is the cost and this is the effectiveness, and this is the taste. And then he told it, depending on what cost, what taste, and the complexity of the task, this is how you should allocate, and this is how you should allocate the to-do list and allocate and basically he hadn't run out at all. So effectively, these firms are capable of doing model routing on their own inside, internally. That kind of structured process could be moved into the model very easily. They just haven't, because hey, it's just not just an optimization which is not necessary right now. But the moment it is, they think it is necessary, they will do it. So I don't really know that model routing is going to be a long-term thing, but it is a negotiating tactic against the firms, negotiating against the price. So it's very helpful right now that we have OpenAI and Anthropic kind of close to each other. It would be horrible if we just had Anthropic. We'd all be suffering terribly. So
tactically, for what it's worth, I like to start with the smarter model and have it delegate to the lesser model. I've been a little confused by the idea that you'll start with a sonnet or even a haiku and have it route up. I could see that working. I think in so many cases that there's always this kind of question of how much are you going to control and really map out the structure of the work that you're trying to do? How much are you going to control the inputs, and how much are you going to map out that structure? Going back a couple of years, I think it was already possible with even like a GPT-4o with fine tuning to get virtually all routine tasks done on an AI workflow basis. If you're a company that employs people to do, roughly speaking, the same thing over and over again, I would bet that with 4.0 and fine tuning, you could get human level performance on a large majority of those tasks. So already, I think we've had for a long time the ability to, if you control the environment and if you map it out and if you're willing to do the evals and the prompts and the fine tuning, you could get there. Obviously, the hurdles there are high. The hurdles have been brought down with smarter models. What do people really want to do? I want to have a smart kind of general purpose assistant that I can throw anything at and then have it intelligently decide when a subtask is something that it doesn't have to put its full force behind. And that does come up a lot for me. So I'm planning a trip to China, breaking news. And, one of the things I'm trying to do is just go through all my contacts on all the different social platforms and be like, who do I know in China? Who follows me that I don't even maybe know in China, but I can, reach out and see if I can meet up with them, or, they might connect me, whatever, of course. Now that's something that if it's, going through thousands of individual profiles and classifying them into, is this something that we should, is this somebody we should consider reaching out to or not for this purpose? Then sure, like probably any number of models can handle that. Certainly I would expect Haiku to be good enough to do a good job and not miss obvious stuff. So, but I want Fable to kind of construct the overall strategy and sanity check the final results and do the prioritization. And I think that's what most people want intuitively from their AI experience. What is unclear to me right now is what enterprises really want. Do they want that experience that they can just give to all their people and be like, hey, here's an incredible source of help, and you can kind of use it on the fly in a flexible way, and it'll help you. It'll, give you leverage. It'll buy your time back. It'll help you focus on the more important things. Certainly a lot of lip service paid to that. Mm-hmm. But the Alex Karp point of view, which I think is kind of implied by this lesser to greater model routing also, is I think more a callback of the workflow paradigm, mm-hmm. where you're not really leaning into the flexibility or general purpose nature of the model so much, and instead really controlling the plumbing, mm-hmm. putting Haiku in a situation where it's like, okay, you are a customer service triage agent,
Mhm.
and you're going to get these things, and you're going to be able to handle 90% of them, and there's going to be maybe 10% that you can't, and here's a taxonomy of those, and we've worked this out, and under these circumstances, then you're going to call up to a higher intelligence model when you need to.
Yeah.
I have a hard, I mean, I guess, it's going to be everything everywhere all at once is a good general prediction. So
Yeah.
it's not like it's going to be one or the other. But I guess maybe the question is like, what is the winning strategy for an enterprise now? I don't have a great intuition for which strategy enterprises should be pursuing or with what balance they should be approaching those two paradigms.
So I think it's very, number one, enterprises only want increase in revenue and decrease in cost, right? That's the basic fundamental. If you can't deliver value that way, and you can't like somehow promise or somehow get some kind of metric that they can use internally to show that kind of return on investment, it's not going to fly. Alex Karp is bringing in this other thing of risk, right? Risk is you can get increase in revenue, you can get decrease in cost, but these guys are going to wipe you out in the future, right? This is the risk perspective, which he's kind of trying to inject in there. And that speaks to basically that enterprises actually are getting increases in revenue or decreases in cost that kind of plug into their existing models. They can kind of see where it's going. And that's why he's trying to inject the risk perspective in there. I'm also very confused about his, they're going to take all your IP. You look at the Fortune 500. Nike. What does Nike have to fear from Anthropic? I mean, Anthropic is not going to go and make shoes. They're not going to like build a shoe brand. They don't have the expertise to go approach athletes to do sponsorships. Like, what exactly is like Anthropic's threat to Nike or the threat to Nike's IP? And then once you start thinking about that, you start about, okay, what about Freeport-McMoRan, largest copper gold miner in the world? Where's the threat? What about, let's say, Linde, which does all of the materials, gases that you use for chemical production? What is Anthropic's threat there to their IP? And once you go down that kind of route, you kind of like discard all of the physical businesses, right? Like Walmart is not going to be disrupted by Anthropic, right? You get all of the physical businesses out of the way. And what you're left with is the pure IP businesses, right? Software production, maybe pharma. I'm not so sure. The paperwork businesses, banking, paperwork compliance businesses, accounting, tax, compliance, regulatory, all of these things which are paperwork businesses, right? Those are all of the businesses where you have IP or relationships built up over years, where if you have an Anthropic go in and they read through your entire workflow and processing, they can basically absorb all of that into the model. So that is where I think the risk is. So when Alex Karp is talking about this, he's really talking about, he's really creating this aspect of fear and risk, but it's only going to affect a portion of the economy. And unfortunately, that portion is the portion that has been growing dramatically in the last like 30 or 40 years. The paperwork, white collar, type of professions have grown dramatically. The physical stuff has not grown a lot. Physical build out in the US has not grown that much in the last 30, 40 years. So I think that's really the perspective that he's coming from. And I don't think and yes, the paperwork businesses are under threat, I think, because, this thing is going to be great at complying with rules and reading the regulations way, way better than any human is ever going to be, right? And I think that is a bridge that they have to cross. So enterprises, they're concerned about the cost of these things. They're a little bit worried that, the return on investment is not there. But on the other hand, okay, I was at the AI Engineers, this is a good segue. I was at the AI Engineers World Fair, first 2 days of this week. And if you don't
Shout out to Swix.
Shout out to Swix. So Swix, he organizes the AI Engineers World Fair. It's been about 3 years now, and he brings in everyone who's involved in basically implementing models in their companies and is concerned about these things. And he brings in a host of speakers. All of the top companies are sponsors and their booths, et cetera, et cetera. And I was speaking to people who were not in tech, right? So I was speaking to a guy who was logistics CTO from the Midwest, and another guy who was, running an accounting firm, like, back office somewhere else, right? So these people were not actually, a lot of them were not actually in Silicon Valley like full time, but they run teams who are using AI to solve customer problems on a day-to-day basis. And so the logistics guy was telling me his CEO is completely AI built. The management is completely AI built, which is why I think the team is there at the AI Engineers World Fair. If not your logistics team, you're not going to send your logistics IT team to SF, right? And they're completely AI built. They have tried working with external vendors before, and they have found it difficult because external vendors have not delivered as fast as they want them to deliver. Which you can imagine sitting out in the Midwest, if you have a local external vendor and you outsource, like a project to them, and they have no idea what's going on. They're like, a year behind the frontier. So his team internalized everything. So they're doing all this stuff internally now, and they're building evals. They're building all these systems. They're using guys like Arise and other guys like Brain Trust, which have started to build out these frameworks to evaluate models, widely when you implement them in enterprises. And they are actually in the day-to-day process of implementing. And as they implement, they see the results because they are very close to that edge. They see that customer service calls or exceptions that used to happen are now getting handled immediately. And then all of the more difficult stuff that they used to have to jump on, they can now start to address. And so they are seeing, I think, the return on investment on a day-to-day basis. And this is very different from, I think, the story that you get from like the big enterprise CTOs, because they're so far away from like the front line that they don't actually know what's going on very closely. They're just looking at the numbers, and by the numbers, the token spend is going up, but are you really seeing the return on investment? But if you go down to that working level and you see day to day on like the customer calls coming in and whether they're getting handled, the handling rate and the exception rate is falling, the handling rate is going up. And they're seeing that on a day-to-day basis, right? So this is, I think, where we are. The guys who are actually implementing and close to the implementations are actually seeing the results. It hasn't really filtered up into the top layer of the enterprises yet, but the CEOs who are AI pilled kind of know what's going to happen, and they've made the commitment and they're making the investment. The CEOs who are not are kind of sitting by and like, oh, we're going to wait around, we're going to see what happens, like, et cetera, et cetera. That's really where we are. And I think it's not really visible. Like, it wasn't visible to me until I went to this AI Engineers World Fair. Like, I think of AI people as just the people on Twitter, right? Like, that's, for some reason, my world has gotten constrained into this like small, tiny world and like, the bubble. And I don't really have this good sense of what people outside the bubble are actually doing or thinking. But you go there and you meet these implementers, and then you realize like all of the stuff that we talk about and we're producing in the bubble is getting used outside. People are learning how to use these tools, and people are deploying and people are using them. People are seeing the return on investment, but it's at the very like micro granular level right now. It's going to take some time for the numbers to filter upwards.
So coming back to the two paradigms, a lot of what you're describing there sounds to me like people are successfully implementing the workflow paradigm. If they can measure things like the handled rate and the exception rate and so on,
yeah,
that by kind of definition means they're doing this more controlled, structured workflow style build out. I still kind of wonder, for me, that work is very quickly becoming Claude's work. So we're in this weird spot again where with this latest tick of the model, certainly, and even before, I think with Opus, the frontier models have a pretty good intuition, certainly better than the vast majority of people, and probably better than all but a pretty small minority of people who have really honed the skill of how to build a more deterministic, structured, AI-powered workflow. And as such, it still feels to me like enterprises mostly should be embracing, let's just pay up for a bunch of Fable and kind of let our people use it. The organizations that are sort of like, oh, we're going to go make GLM 5.2 work for whatever. We don't need that. You don't need super intelligence to write your email, what have you. I think that's true, but I think we're still in this kind of weird middle moment where if you want to economize and you say, oh, we're going to have our people set up all these workflows and then we'll be able to use an open source model and we'll save money. I just think you're signing up to go kind of slow.
Mhm.
And just, have a lot of committees and a lot of people in meetings talking about how do we do this and how do we eval it and whatever. And it just feels to me like there's still a lot of advantage in just throwing some high value tokens out to your whole employee base and basically saying, develop your own workflow solutions on a kind of as needed basis. And by the way, the frontier model, which you have, is really good at that. And, maybe you could have a strategy that's like, and specifically we want to delegate to, our own internal GLM 5.2 inference capacity or, whatever, inference partnership or provider we have. But how much does that save versus just having Fable, kind of natively delegate to Sonnet and even Haiku, where it's clearly going to be more closely trained to do that well and know when they can handle the tasks accurately and prompt them well. And that I really don't have a great sense for. I was just talking to a former investor of mine, still an investor in the sense that we haven't liquidated the investment yet. And he's working on a sort of red hat for AI kind of thesis at the moment. And so we were talking about this, and I kind of came to the same conclusion with him. I think as so often, I think like the tasklets, the Lindy, not the Lindy you mentioned, but the Lindy AI, and the illicit product folks are really at the frontier of this, where they're really wrestling with how do we carve out any relevance for ourselves in a world of Claude can do it all, in a world of Claude for science.
Yeah.
And their answer is kind of like, we have to be the best at routing so we can deliver results without compromises, but do that as efficiently as possible. And we also, of course, have to be cross-provider. That's the one thing that the frontier labs are probably not going to do. Although we even see that a little bit, right? Like there has been some, direct integration or direct sort of plug-in type relationship between Claude and Codex. But they sort of have to do such a great job of that they can then amortize the cost of that work across all their customers and then deliver, ultimately savings to customers relative to what you could get on your own. Really hard given the price discrimination between the API and the subscription level. Although again, we have to remember for enterprise, the 150 seat cutoff that Anthropic has is another really weird discontinuity in all these curves. So depending on which side of that you fall on, you're in a very different world. price discrimination wise. But I think Tasklet and Lindy, they've both put things out recently where Tasklet's strategy was basically like, Claude is the only thing that's good enough. We're just going to ride Claude and make the best product that we can and grow as fast as we can. Mm-hmm. And Lindy had a similar strategy. They had a lot of different models that you could use, but Claude was the default for pretty much everything. And they were both like, we're going to prioritize making this thing work, even if it's low margin, or at times Tasklet was even negative margin. Mm-hmm. Lindy has also been, I think without disclosing numbers, pretty transparent around inference is their biggest cost. So, a little swing on inference. Tasklet even said that when 4.8 was using a new tokenizer that was 30% more tokens, they opted not to move from 4.7 to 4.8 right off the bat, just because of that 30% input token bump, which was enough to kind of mess with their economics.
Yeah.
So, but nevertheless, they couldn't compromise on customer experience. So they sort of waited, build with Claude until such time as they could finally get to the point where they could start to diversify across providers. Yeah. And notably, this has just happened for both of them, with Tasklet bringing on other inference providers, I think leaning into OpenAI most of all.
Yeah.
Lindy actually starting to do open source inference, but with a really intensive process, with many failures under their belt of previous models that they thought might maybe be good enough, and they weren't, until finally they hit on one that they were able to get confidence on and actually launch to not all use cases, but at least enough use cases that it has kind of meaningfully changed their economics. So it seems like that play, if I'm kind of advising an enterprise or advising like a Red Hat for AI type company that wants to go serve enterprise, I think that same strategy is kind of what I would say. Like, the frontier models still have the juice where if you're using them on an ad hoc basis, you're going to get value. You're going to know where that money went. And even if you're structuring things, which is a good goal to have, you probably don't want to rush into trying to structure them with a much cheaper model, because it's only recently been possible with a lot of work to get comparable results. Yep. And even if you are going to, finding you can do that, who's going to do it best? Probably still the frontier models, even more, than your own people in a vast majority of cases. So, and then while you wait too, of course, they're doing all this integration, right? Of the native routing. So yeah, I guess I kind of still feel like all roads lead back to Fable, sort of, if you're really going for performance. And if you're not going for performance, or you're really prioritizing risk, or you're really prioritizing IP, then I think you do have another question on your hands of just like, how long can you do that before? Because in addition to Cloud for Science, they also just announced a whole biomedical initiative, right? They're going to go try to cure rare diseases, which I think everybody should be excited about, except for maybe the pharma companies that are trying to do like highly controlled, structured build out type things, while meanwhile Anthropic is just revving tokens at the frontier and potentially coming for you real quick.
So the way I saw Flo Crivello's Altimore's post as they started to switch into open source, and he was explicit that they'd spend so much money on Claude, and open source was finally good enough. I think the open source being finally good enough is just an artifact of the slowdown that the frontier labs have had. If the frontier labs had been allowed to release Mythos Fable level models in February, like we wouldn't be having this conversation, I think, and the pricing would have dropped. I do have a endpoint that I think what enterprises will eventually look like. A lot of what businesses do is they try to standardize in order to reduce cost. So if you were like a, let's say sole entrepreneur, and you have someone who comes into your restaurant and you don't like the look or they're making too much noise, you always have this management reserves the right not to serve you and to ask you to leave, right? So you would be like, okay, I don't like you, please leave. But if you're McDonald's, you need to have like rules and structure, because if you throw people out, and like if your manager has, tends to throw people of a certain kind out, and it's discriminatory, then it's a problem, and then you're gonna have to like face up to it, and you're gonna get sued, and you're gonna have to like fix it. So in order for you to follow the rules and not get into that kind of position, you create this level of compliance and structures, et cetera, and you create this entire like structured workforce and training, et cetera, to get your frontline staff kind of into that consistency zone. All of that kind of melts away with a good AI, right? So if you have a good multiplayer AI which can hold the context of the entire enterprise at once, then all of the intermediary paperwork and red tape melts away. And so you could have like your manager at McDonald's say like, hey, this is the video of the guy, like you don't feel comfortable, am I allowed to kick him out or not? You don't need the training, you don't need all of this stuff. You can make a quick call, and then the model can be like, okay, let's look at all the rules, and like, is this going to be discriminatory? Like, is there a cause? What do we need to document? And the model could say, okay, just take a photo of this and this and this, and you can proceed to do so. And this is the way to do it. You call the cops. You don't do it yourself. You call the cops, and you show them that this is what happens, and they will be the ones that will do this. Or we have a private security engaged, like you can call them. So all of this stuff that we do on the enterprise does on a standardized basis can become customized now. And that has to do with your clothing, like your clothing measurements, your whether they fit well on you, like the way your customer service personnel talk, the vibe in your shop. All of this stuff becomes customizable, because you can have a central entity that can hold the entire context of the business. And once you have that, then you can have your people are not doing paperwork anymore. Your people are there to make decisions. And that is the primary goal. Like, your people are there to like make vibe calls and then make decisions based on those vibe calls on how they want like the set of decisions that they're allowed to make to be able to go forward. So I think eventually all of this, as you pointed out, all of this stuff about like having different models address blah, 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 all of it kind of melts away, because the model itself will allocate its own compute. The model will be able to allocate the appropriate amount of compute for the task that it needs to do. And when we talk about all these different models, what we're saying is compute. What we're saying is, how much compute should I use to solve this task? Is that compute going to be deployed using a small model which thinks for longer? How much thinking time should I give it? And this is where we have all of this low, high, sonnet, haiku, all of these names. They all boil down to how much compute do I need to use to solve this task? And this problem of like not being able to allocate, not for the larger model, not being able to allocate compute appropriately is what all of this fragmentation is. The moment the larger model solves that problem, the moment you solve this problem of being able to judge how much compute to allocate to a certain task, all of this stuff melts away. Then you're just like, okay, who does the task best? If you have a context window which is large enough for the entire enterprise, you don't have individual instances anymore. You don't have like transfer of context and summarization and all. The model handles all of that. It plugs in right into your CRM and databases. So we are on this kind of path towards there. We will eventually get there where you have one model that can decide how much compute to allocate, and also like have the context of the entire enterprise, and be able to talk to individuals within your company and kind of advise them, and be able to drive like strategy from the CEO level down, and like have everyone be on the same page at the same time. And that's going to happen. We're on that journey towards there. This is why I thought Claude Tag, this is why I've been like, I've been really like, Claude Tag is excellent, because Claude Tag is the beginnings of that, right? Like I've had this vision for a while. Claude Tag is they've solved multiplayer. They've solved like able to handle independent threads, able to manage context, like large amounts of context. Now it's a question of just getting it better and better. They've solved the 0 to 1 problem on multiplayer. Now the problem is the 1 to n. And the 1 to n, as Peter Thiel points out, is actually easier than the 0 to 1. The 0 to 1 problem is the hard problem. And I think this hasn't been very well recognized in I think generally. Andre Karpathy, made a post, and people are like, "Oh, look, now he's promoting Slack. Like, you join. You're one of the greatest AI people in history, and you join Anthropic, and all of a sudden you are an influencer for SaaS, right?" And they really dislike that Anthropic is coming into SaaS, because SaaS is where the easy money for tech people have been. Like, consumer, you go in, you get hit on the head a couple of times when you're young, you come out, you do SaaS. And SaaS has been like stable, and you've been able to make money. Anthropic is coming for all of SaaS right now, because all of SaaS melts away as the model becomes the connective tissue of the enterprise. All of SaaS melts away. And I think people are still having, like Alex Karp, are having trouble like wrapping their minds around what's going to happen and the pace at what's going to happen. I didn't expect to see Claude tag so soon. I thought it would be 2 or 3 years from now. And so things are actually happening way, way faster. And Anthropic is like downplaying it so much. Like, they put out a tweet and they're like promoting it like a SaaS product. Like, how could you? You can have something, if you solve the 1 to n problem, you could have something like a Claude tag running US government. Like, it's the same thing. It's a singleton which runs for multiple people and has a shared context and can keep the threads separate and can follow the rules set. It's the same thing. They're on that path. They've crossed the 0 to 1. So yeah, it's good that people are optimizing on smaller models. It's great, but that problem has basically been solved, kind of. Like, I think the allocation of compute is almost there. And I think we're only seeing it because they slowed down a bit because of the regulatory issues. And I think by the end of the year, I think it'll be more evident that, how powerful this paradigm is going to be.
So is there a steelman of the Alex Karp thing? And how much does it really center around trust and sort of IP concerns, or the idea that you're sort of, we're all kind of training our replacement from the sort of highest level of humanity, training the AIs, generally down to the individual customer service rep that's now babysitting bots. Is there more to the steelman case than that enterprises are worried that they are doing that too and kind of training their own future competition? Or is that really the heart of what you think he's channeling?
I think he's actually using the exact same selling point that has always been used by enterprise SaaS, which is you have to own your own stuff. And that is why people had racks on premise, 30, 40 years ago. That's why Amazon created GovCloud. That's why you have all of these VPCs, et cetera, et cetera. Like, it's the same thing, which is you have to have your own setup. You can't depend. And then within that own setup, there are vendors that give you that setup, right? And it is why Microsoft, for example, has a business, because Microsoft was already inside enterprises, banks, et cetera. And banks are not going to move to Gmail, right? Gmail came out after most banks were founded. Banks are not going to move to Gmail. Banks are Microsoft Outlook. You're not going to change that. They're on Microsoft Teams. It's basically impossible, right? And you can. It's the same selling point. The problem is, I think, for some industries, if they're sheltered by government regulation, they get stuck, right? Like, as banks cannot really easily migrate, or have not traditionally been able to easily migrate to better software vendors. So they get stuck in COBOL, or they get stuck in these things. So Alex Karp is like IBM now. He's basically trying to sell lock-in to enterprise into these older, inferior products, and it works. I mean, IBM has had a business for years, right? Like, for 30, 40 years, they've been servicing mainframes, while everyone has else has moved to cloud servers, right? So it can work. And the key difference is that the AI can also do migration much more easily. So the cost of migrating is lower. So he's got to push the trust angle. The cost angle is not going to be enough. He's got to push this trust angle in order to maintain. But they'll come up with new things. They'll come up with like, oh, you can manage your own singleton inside, and the Claude singleton outside will just come in to do maintenance on your singleton once in a while. Like people will find like sales strategies around this stuff, right? So it's going to be a battle. It's going to be a battle. But the firms, these frontier labs, have raised so much money, and there's only two ways: you either eat someone else's lunch, or you create new abundance. And as long as like the new abundance seems slow, they're going to eat someone else's lunch. They're just going to drink the milkshake, right? So
do you think he's right about the attitude? I mean, when he says companies don't like the frontier labs and they love us, obviously he's talking in his own book about how much they love Palantir. But do you think that they really don't like the frontier labs? I mean, in some ways, the general purpose intelligence on demand, pay by use paradigm would be like the ultimate dream for the enterprise. And clearly the adoption has been super strong. Do you think that's true? And if so, like, why do you think it's true?
So I think a lot of this is driven by where you are in the food chain. And if you're in the food chain and you have to pay for a product, that upsets you. And if you have to, like, if like the Uber CTO, you've run out of budget and you have to go back to your CEO for more budget, that upsets you, right? Enterprises, this is a cost. They're not happy with the cost. That's very clear, right? But they're being forced into it. They're being forced into it by competition, by CEOs who are, AI forward, and they dislike it for that reason. That change is coming at all. They dislike that fact, right? Palantir at this point has a very clear kind of value proposition when they go in. They can tell you, this is what we're going to do, this is how much it's going to cost, and this is how much money you're going to make, this is how much you're going to save. They can tell you they're going to help you prevent fraud, and this is how much your fraud rates are going to go down. So they have a clear value proposition. And so upfront, you know how much you're going to pay before you engage in Palantir. You don't get like sticker shock with Palantir, right? The problem for the labs is people are getting sticker shock because they go in and they implement, and then you're paying on a per token basis, and all of a sudden the token costs like explode. And so you get sticker shock, and then you have to change your budget for the year. That's not a very happy thing for any enterprise CTO or CEO to face. So that's annoying to them. The frontier labs are also horrible at sales, right? They're not. You look at IBM. IBM has like 70% of the staff are basically sales engineers, and the sales engineers are there to basically help you implement, maintain, do all the grunt work, etc. The labs are not doing that. The labs have decided, especially Anthropic, has decided to do this very lean structure of having almost no people at all, and just putting out the models, and then just saying to like these enterprise teams, here, you can go ahead and use it or not use it. And I'm, the CTO is on, I'm signing 9-figure deals on the Uber over here, right? Like that guy isn't going to come and jump on your customer sales calls and like, oh, sure, we'll help you do this, and our team will address this like next week. Nah, that's not happening, right? So the level of like customer service that is expected for enterprise SaaS is not being provided by the frontier labs, and they're not in a position to provide it. That's why they started this whole FDE program. But the FDE program, people thought it was a sales engineers program. It's actually a program to extract data and workflows and implement them inside the models themselves. And that is what Palantir, what Alex Karp is alluding to. He's like, the FDEs are coming in and they're not there to help you. They're there to absorb your workflows. And once they absorb your workflows, you won't have a business because it'll be taken. And it's true. It's absolutely true. That's what, we spoke to 2 OpenAI FDEs, and they went into a company that Thrive owned rather than an external company. And as they went in, then they, took apart the workflow and they're basically absorbing it. And they said that the intention is to absorb it in the next round. So yeah, that's where the enterprises are upset about costs. They don't like paying costs and they don't like sticker shock. And it's a function of the sticker shock that I think they're annoyed. And this whole open source model thing is about the sticker shock. Again, these are all negotiating positions. And having the open source models helps enterprises negotiate against OpenAI, and helps CEOs negotiate against the CTOs. The CTO wants budget. Use GLM 5.2. So CTO has to decide: do I use GLM 5.2, or do I put token spend limits of some kind on our engineers? Then they have to rethink. So they're trying to get the costing into the proper bound again, and they're hoping that it doesn't blow up again. So if Uber CTO can say like, okay, I got $3 billion allocated to AI, and we're going to use Anthropic, but if it's too expensive, switch over to GLM 5.2. That's what you have to do. And so that's what they're saying. They're saying that if it's good enough, switch over. Maintain the cost within that bracket. Don't push the cost out. And the model companies will basically negotiate to take that spend, right? The model companies have a 90% margin. So they will try and negotiate their pricing in order to come in and get 80 to 90% of that budget that's been allocated. And that is happening right now. So
overall, I feel like it's going to come down to political economy, in the sense that it's just really hard to imagine American business broadly, which is probably the most dynamic business culture in the world. Maybe China would like to have a word about that, but it's just really hard to imagine how they do all this stuff and navigate all these things, and even just the budget cycle and all the process that they've had. It's something as simple and fundamental as annual budgeting just isn't really gonna work that well anymore, I'm afraid. And I do kind of bet on, if we're in a laissez-faire market, I do think I bet on the big tech singularity to ultimately win over a lot of legacy companies that are stuck in those processes, even if they're really trying. And the question then just might be, are these companies allowed to enter new markets, right? And this connects obviously to the equity sharing proposals that we've talked about a little bit, and which are potentially getting more real. In a way, you can imagine from a purely selfish standpoint that some equity sharing where everybody gets an account where they can look at, how's my slice of the AI pie doing today. I could see that being in some way the most genius move that the frontier companies ever make from a purely selfish standpoint, because if they even give away, right now, apparently we're talking about 5% of OpenAI being given to somebody, something, is it going to go to the federal government? Is it going to go to households? Is it something else? I don't think we have any clarity on that. Will they be liquid is another, interesting question. I think when the precedent for just handing out shares, from what I understand of the post-Soviet world, was that didn't really work super well. They kind of got cornered, markets got cornered, and people didn't really realize what they had. Anyway, there's a lot of practical implementation questions there, but 5% I think could look really small relative to and even 50%, in some sense could look small relative to the binary question of, are these companies going to be allowed to enter into new markets and compete directly across a vast, super wide array of different markets against all their current customers? If they are allowed to do that, then it seems like it probably more than doubles their valuation versus if they are not allowed to do that. And my gut kind of says, give away, if you're them, like give away half the company to the public, so everybody has a little ticker that they can watch, so they're all kind of cheering for you. And then you'll probably be allowed to come do these things. And like Amazon, you'll probably also be really well loved at the consumer level. I think Amazon, as much as there's sort of hate in certain corners, you look at their favorable brand rating and it's like super high, right? I mean, I think the last number that I saw were in the 70s, maybe even to the 80% range, which is super high. And why is it so high? Well, they do what people want, right? They give great selection, fast delivery, all the classic things that, Bezos says will never change, great prices. Yes, they're like squeezing people left and right. Yes, they are doing, they're kind of doing exactly this, right? They look into their small business marketplace, find hot sellers, clone products, sell them for half or less in a lot of cases. And there's a whole kind of Lena Khan school of thought that's like, hey, this maybe shouldn't be allowed. Like this is an abuse of power, and we're sort of hollowing out our small business culture by allowing this big tech company to come in and make, and undercut you so dramatically based on the data advantage, the visibility advantage that they have, and they don't even need to make margin on it. So should we allow this or should we not allow this? The public broadly seems to come down time and time again on, I want the best stuff I can get for the cheapest, the fastest. And, the small business owners, like, yeah, I pay lip service to that, but I'm not willing to pay twice as much on an ongoing basis for all these random products that Amazon would have sold me directly for half, just so I can sort of, generically, philosophically support small business. Now you take that to the enterprise level and you're like, oh, hey, Anthropic is coming in and revolutionizing drug development, potentially. We're still somewhat speculative on that, obviously. But it's not good for Eli Lilly. I don't think anybody cares, especially if they have a little slice of Anthropic that they can watch tick up into the future.
Yeah. So speaking of that, Anthropic took a stake in, Micron has taken a stake in Anthropic, and Anthropic is cooperating with Micron. So that is actually happening, right? So as you said, this kind of taking a stake. So Anthropic needs memory. They want to co-design the memory because they don't have the capability, but that would also be, they can't compete head to head with Micron. Micron has all the manufacturing as well. So they go in and they're a buyer. They're strategically, partnering with Micron to design the memory and the chips, and Micron takes a stake in Anthropic, right? So there's cross shareholdership. So that is actually happening, as you kind of alluded to. I don't know to what extent Anthropic will ever. I think the pharma thing is a little bit more. I think because Dario's view in Machines of Loving Grace was an AI that can do the entire pharmaceutical, the pharma research process from end to end, from idea generation all the way through clinical trials and to the end. And I think it is very difficult for them just to offer API access to, let's say, Eli Lilly, and for Eli Lilly to be able to implement, because it's very difficult if you don't know what the AI is capable of being able to design workflows that the AI can use. And so I have thought for some time that this will happen. My expectation was that Anthropic would IPO and a bunch of people from Anthropic would start leaving in order to found companies that basically attacked each of these markets separately. I don't see the non-AI native companies from being able to be this kind of like quick to do stuff. I expect the AI native companies to be the ones. So there are a few ways this can play out. One is acquisitions. So Anthropic, I think, would maybe buy Slack or maybe buy Salesforce. You can kind of see it, like they really like Slack. Cloud Tag is launching Slack. They kind of want to make it their central kind of platform. And I could definitely see them, at some point, if they're like at a couple of trillion valuation and Salesforce is at like a couple of $100 billion, there could be a deal to be done. Like, okay, I'll pay you $100 billion on take Slack, right? And Salesforce gets $100 billion in cash. They get to stay as a CRM system of record, and Slack goes to Anthropic. And so you can start to see this kind of deals happen, like this kind of taking over of key strategic assets, and not really like that you buy shares in Anthropic because they're going to pay you for the asset. You can use those funds to buy shares in them. They're happy to have you as a shareholder, but it's not like a special stake or whatever. It's just like the shares are available, you can buy them, but they will give you the money to buy them, right? By buying out your assets. And I think, for example, like if Anthropic wanted to enter like logistics or whatever, and you need physical facilities, yeah, they would have to buy them, right? You have and that buying them is an exit, and those guys who exit can buy shares in Anthropic again. Like that system of acquisition can support itself. And those buyers have the choice to whether buy shares in Anthropic or do something else with their cash. It's not like limited to only when OpenAI gives these shares to the people can't sell them and buy something else, right? They're limited. So this is actually less valuable than actually just having the stock outright and being able to sell the stock in the market and buy something else, because that option of choice gets taken away. And it's more valuable if you have that option of choice, if the person has that and like they're able to sell. But the thing is, a lot of people who get these shares won't understand their value. This is the fact. They won't understand the value. They won't understand of superintelligence might be more valuable than anything else on the face of the earth in like 10 years. They won't understand that, and they would sell early, right? Same thing that happened with Bitcoin. People sold early. They didn't understand what it was going to become. So yeah, there are ways out of this where it's just, with our existing commercial structures, just pure acquisitions without any, crazy stuff like offering shares to the government. You can resolve all of these things. I think the offering shares to the government is really a political move. It's to kind of diffuse the amount. What Sam is doing is like, look, we can either have the Dems come into power and take it away from us forcibly, or we can give it voluntarily and decide the terms of which, the ownership is structured. And that is really what he's aiming to do. Like the 5% is obviously a starting stake. If Bernie Sanders wants to go to 20, I'm sure Sam would go to 20. But after 20, like what can you do? What can Bernie Sanders do after that? The state already has a stake in the firm. What else do you want? And that is the answer that I think like the Bernie Sanders guys can't come to, because what they really want is to stop progress. They want to freeze like wages and progress to people who are wages, progress, rents in New York. To the people who already have homes, they want to freeze them so that things don't get more expensive. The people who already have wages, they don't want it to get taken away. That is what they're asking for. They're asking for a freeze. And the way they go about it is like, I'm going to take your money. But here, I'm going to give you the money. What happens next? They don't know. Because you can't stop progress then. Like that's what the people want. The people want the stop of progress. So he's created a political conundrum for the left wing now. And everyone knows that the left wing is probably going to have more power come November. And so people are making their bets now. I saw, Jared Kushner's brother's wife, Carly Kloss, she was on a interview with Amy Chang, I think yesterday or the day before, on a podcast. And she comes out and she says she's a Democrat. And she comes out and she says, like, I've never met President Trump. We live in St. Louis, and we are like unaffiliated with, all of that stuff, right? And the reasoning is because as stuff comes out about like the Trump crypto stuff and like, billions of dollars, etc., there are many, many Democrats, lawyers who are sitting around collecting evidence in DC right now. And the winds will change. And these people, yes, President Trump plans to pardon a bunch of people. But the thing is, like, the proceeds of this are already under scrutiny. And as those proceeds get used for other things, like, they will find ways to, put people into prison. There's a guy called Tanner Greer. I don't know if you know him. He goes by Scholar Stage on Twitter. He writes. He's a lawyer. He's right-wing lawyer, but he's right-wing kind of like non-Trumpy kind of Republican lawyer. He's like, look, I told you guys not to do this. And when the Dems come into power, hundreds of people are going to go to prison. Hundreds. So this is where things are right now. I think, Sam is kind of getting ready, and everyone is getting ready. Like, you have to be ready because the winds are going to change. And you have to be careful because, Trump can pardon a bunch of people, but he's not going to pardon like analyst number 2 on investment bank number 5's desk, right? And what the Dems have done before is in the Clinton, or what these lawyers have done before in the Clinton years, is they've gone after like the smaller people. And sure, the big guys get away, but then it inflicts this like level of fear on the staffers, and it makes them like really aware. Like, Trump isn't going to like pardon like 10 million people or whatever. There are like thousands of these like Republican influencers and like right-wing people, and it's all being like tracked, right? Is he going to pardon Tim Pool? Tim Pool took money from the Russians, right? Like, is he going to pardon Tim Pool? Tim Pool is an influencer. I don't know. So I think there's a bunch of this stuff happening in the background that people are getting ready for, and Sam has played his cards well, because the 5% looks good for the Republicans, and it looks good for the Democrats, and it diffuses the situation. And these, if you discover an ASI, it's going to be an infinite money pool anyway. Like, why do you care if it's 5%? Like, give up 20, give up 25. Give up 25 and become a tax-free company, right? Like, maybe you don't pay taxes anymore. Give up 49% ownership, whatever, right? So I think it's a very odd place because of this. The infinity number on like the future proceeds make all the numbers like wonky, and it makes everything a little bit more. And Sam is a good player. I mean, he's excellent. Like, what does Elon do now? Does Elon offer a 5% stake? What does Dario do? Does Dario offer a 5% stake? How about a 10%? What about Mark Zuckerberg? Mark Zuckerberg is already public. He's not going to give you a 5% stake, right? Like, it's just such genius, genius politicking, absolutely genius politicking. So I don't know, how do you feel? Like, what, like, Sam has made this is obviously a political move. Like, how do you feel about the politics and the appearance of this right now?
Well, I was just reading commentary from Dean, friend of the show, Ball, this morning, who officially starts at OpenAI on Monday. He did say he's not talking with Sam or anyone at OpenAI about this yet. So this is just, and this is also kind of, continued indication that he's going to hopefully be free to speak his mind even once he takes the role. But he basically said he thinks it's a viable, maybe even a good idea if the ownership goes to households, and a terrible idea if it goes to the government. And that, I think, does resonate with me. I don't like the idea of having the federal government, biased from one company to another, trying to pick winners. I think we still risk a lot of those dynamics, even if it's just broadly distributed to households. but it does seem like it could be a lot worse if it's something where the government is a direct stakeholder.
Yeah.
And especially if the government then becomes dependent on this asset as sort of, some sort of backstop or, collateral for its borrowing. And we just, run it up even further. And then we're kind of now in this weird thing where the stock price, I mean, we already are kind of in a world where the stocks can't go down or we have problems. But you can imagine, if that now starts to even threaten, we're still in a world where the government, I think, can be the bailout, be the sort of equity investor of last resort or whatever exactly is needed. I don't think we want to play with, the kind of third rail of like intermingling the government's balance sheet with these companies to the point where they can no longer do that because they sort of already, are in that same path of contagion. So, I'm probably a less sophisticated thinker on this by a significant margin than somebody like Dean, but I do think the household distribution sounds a lot better. I do have big questions around that when it comes to how is this consistent with OpenAI's mission? How does it benefit all humanity? Putting it all in the hands of 5% of people, I think, is a very rough look for a lot of the commitments that they made over time. Would they have to bundle this, or would they want to bundle this with some sort of universal basic compute commitment as well? They have done that with medical. They did make their latest and greatest medical experience free and unlimited globally. So they are making some moves in that direction. But I think it's going to be a tough sell to the other 95% of humanity to say only Americans get any of the upside, especially because all the same concerns that we've been talking about for American companies, probably, as we talked about with Europe 2031 not too long ago, like all those worries and risk vectors probably apply even more to other companies around the world.
I think I've always thought that the whole, labs being like, okay, we're going to have like benefit all of humanity thing has always like not worked for me, because I'm like, it's not possible. And it's like, you would not be able to like kind of execute that in the US, I think. So I've always been like, okay, sure, like that's what you say, I'll take your word for it, but I don't really believe you, right? So I think that's the fact of the matter. And I don't really see that as like, a feasible thing for them to do, right? It's not really that feasible. Let me segue here, and we have with us our first guest of this morning. We have Kunle Olokotun. He's the Cadence Design Professor of Electrical Engineering and Computer Science at Stanford University. But to the hardware engineering world, he's widely recognized as the father of the multi-core processor. In the late 1990s, his Stanford Hydra project proved that the future of computing was not about making a single processor run faster, but about putting multiple processors on a single chip to handle many tasks at once, a fundamental design that powers almost every server, laptop, and mobile device we use today. Today, he serves as co-founder and chief technologist at SambaNova Systems, a company that has completely rethought how artificial intelligence processors are built. Instead of relying on traditional graphics processing units, GPUs, which constantly shuffle data back and forth to memory, his team developed the reconfigurable data flow unit. This is a chip designed to stream data continuously, like an assembly line. This approach drastically cuts down the time and energy required to generate AI responses, specifically for complex, multi-step autonomous AI agents. He joins us at a critical moment for the AI industry. Over the past few months, SambaNova has launched its massive SN50 processor, announced a groundbreaking architecture partnership with Intel to split AI workloads across specialized chips, and secured a massive enterprise rollout with Vista Equity Partners. With the report circulating this week that SambaNova is targeting a staggering $10 billion valuation, Kunle is here to explain why the era of using one giant GPU for everything is coming to an end, and how data flow architecture is making highly advanced AI practical and profitable for the enterprise. Hi, Kunle. Welcome to the
Hi,
show.
Prakash. Thank you for having me. Hi, Nathan.
Hi, great to meet you. Quick check. Did we say your name right?
I think you cut out for some reason.
Oh, okay.
Did we get your name correct?
Yeah. My name's just spelled phonetically, so you just pronounce every letter, and so you got it right.
Amazing. Prakash, you take it. I'll refresh and come right back.
Okay. So, Kunle, this is, I think, a critical moment in the chip industry because everyone is complaining about GPU prices, especially our friend Jensen Huang, NVIDIA's power and influence on the market and the profit margins of NVIDIA.
Right.
And can you tell us a little bit about how SambaNova has this different paradigm that addresses kind of the issues with GPUs and brings down the total cost of ownership for enterprises?
Yeah. So SambaNova was founded 2017, and it was kind of the out of ideas from Chris Ray, my co-founder, who's also a professor at Stanford and a certified genius. The idea was to, if you could bring software algorithmic ideas together with hardware architecture ideas, and as you said in your introduction, I've been working in the hardware architecture space for a long time, and starting from a clean slate, how would you design an architecture that's optimized specifically for inference, right? So, everybody thinks about GPUs as a kind of general purpose computing substrate, right? But originally was designed for graphics, and then they kind of made a foray into kind of high performance computing. And for high performance computing, of course, you need a lot of matrix calculation capability. And at some point, people realized that, hey, you could use these things for executing machine language of machine learning models. And the core of machine learning, and of course AI, is matrix multiplication, right?
Yeah.
But when you want to train a model, right, clearly the core of the problem is, how quickly you can do very, very large matrix multiplications. And so what happened is, over time, GPUs put more and more of their silicon area into the exercise of making these matrix multiplication capabilities better, using the tensor cores. But once you've trained a model, right, and you train a model once, you now need to use that model, of course, and that's the inference problem. And the inference problem is not really a compute problem, because as the models get bigger, you now need to move the weights and, of course, what we call the KV cache, into the compute units. And that is essentially a data movement problem, right? And it's a data movement problem, from the memory to the compute units, and it's a data movement problem from your chip compute unit, and of course you need to scale to multiple chips in order to handle the computational requirements especially for very low latency, high speed inference. And so our focus was, how do you design an architecture that minimizes the overhead of communication, and make sure that you can most efficiently use the core resource in the system, which is the memory. And it's the memory. Memory isn't just one thing, as you all know. It's a hierarchy of memories, right? And so
Right.
the key thing is, how do you orchestrate that hierarchy? How you orchestrate the communication such that you keep everything as efficiently utilized as possible. And if you do it right, you can get a 5 to 10x improvement over where GPUs are today.
It strikes me that NVIDIA's kind of solution around this has just been to increase the bandwidth rather
Right.
than through NVLink and advanced HBM integration and software optimizations like TensorMT, VLM.
Yeah.
So are they actually trying to brute force their way into this?
Yeah, I mean, you really, of course, want to continue to get peak improvements on HBM bandwidth and chip-to-chip communication by using the latest technology. But then the key is, how effectively do you use that bandwidth? How effectively do you use that communication? And do you make sure that you don't waste it, right? And so, whereas GPUs are often running at, maybe 10 to 20% of the capabilities of the resources, right? The bandwidth and the memory bandwidth and the communication resources. Our goal in a SambaNova system is to push that to be 70 to 80% of the peak. And so the idea is, yeah, everybody wants more capabilities from the underlying resources, but the key is keeping those resources as effectively used as possible. And of course, that gives you more benefit for the cost that you spend on providing higher memory bandwidth with the latest HBM and higher signaling frequencies and communication bandwidths between the chips using the latest variety of NVLink and so.
For a lot of the chip users, they often focus on this number, the model flops utilization, the MFU. What is your North Star as you guys are designing the chip? Like, is that the strongest consideration, or are some other metrics or numbers things that you focus on?
No, the speed of light of doing inference is really, especially if you want high speed inference, right? So everybody, knows that we're in the agentic AI era. And so what one wants is what we call premium tokens, right? So premium tokens are tokens that you can charge the most money for because they are premium. And why are they premium? Because they come from very large models, so they're accurate, but they also are provided to you at high speed, so that they're useful from the point of view of an agentic environment that needs many turns through the models and potentially has multiple models that interact, right? And so the question is, how do you provide those premium tokens? And you provide those premium tokens by having very fast inference, and that is not going to be limited by floating point. It's going to be limited by moving the KV cache and the parameters from the HBM memory to the compute chip, right? And so we like to think of this as memory bandwidth utilization, right? So the speed of light is one, right? Is that you use your memory bandwidth completely for one thing, or maybe two things: moving KV cache, moving the parameters from the HBM to the compute unit, so that you generate when you generate each token, right? And so, in fact, in many instances, you're underutilizing the flops on the GPU or the compute units, because in fact you are running a memory bound problem, right? And in fact, a lot of the problems that one runs on GPUs, and especially inference, are in fact not compute bound; they are memory bound. or memory and communication bound.
Could we zoom out and just ask you to kind of taxonomize the whole chip space, if you would? I mean, this is a big question, but I think people are familiar with things like Cerebrus, which obviously has this like giant chip and has like a ton of memory on chip. We've seen a number of instances where people are, burning the transformer architecture directly into the silicon with varying degrees, I think, of flexibility still remaining as they pursue that strategy. And I guess I'm curious as to how you see the kind of menu of big different strategies, the big different bets that people are making. Mm-hmm. And then also how you see the strengths and weaknesses of each. Are there, when you talk about KV cache, for example, right? Like maybe we're in a world where we just keep pushing attention forever, and there's, it always kind of has to be dense, at least at some layers. And so we're kind of in, of N2, till the singularity. And so that is like, a persistent bottleneck. But maybe we're in a world where somebody figures out a state space model thing, and now we move to a more like linear paradigm, and the KV cache isn't the constraint that it is today. So there's many different directions you could go with that, but I'm just really interested in your kind of high level map of the different strategies people are pursuing and what you might believe that would tip you to think, this really pays off in this world. This, maybe pays off in this other world. If there are sort of cliffs, and I don't know what those would be, where, if models hit a certain size, then a certain paradigm won't work anymore. Be interested to hear your kind of thoughts on that as well.
Yeah, that's a really interesting question. I think maybe you can think about it along three different axes, right? So one axis is sort of your flexibility versus specialization axis, right? So extreme flexibility might be something like a CPU, or to some extent maybe a GPU, which is this instruction-driven execution engine, right? And so can be pretty flexible, but of course you always pay overhead for executing instructions, right? And you pay overhead in terms of silicon area and in terms of time, right? And then on the extreme of that axis would be something that would be very specialized for a very specific algorithm, right? And so if that algorithm change in any way, then that piece of silicon would no longer be useful, right? And fixing your architecture to transformers and burning your weights into the design might be an extreme case of that, right? But I've learned never to bet against the innovation capabilities of software people and algorithm people. And so, I've seen, even over the time that I've been looking at ML and AI, that there's been this tremendous change in algorithms. And of course, now we're kind of fixated on transformers, but transformers even aren't just one thing, right? You've got various types of different transformers. You mentioned state space techniques. You mentioned the fact that the people are coming up with different ways of doing attention, right? And so I would be very wary of a sort of kind of fixing any particular algorithm into architecture, because then you can't innovate, right? So that's one axis. Another axis would be sort of how you manage what kind of memory you use, right? So if you kind of think about along the memory axis, right? So you've got very fast SRAM on chip, probably half a gigabyte. You've got hundreds of gigabytes, or maybe tens of gigabytes of HBM off chip, right? In HBM, and then you've got terabytes of either flash or DDR, right? So that's the memory axis, right? And then maybe one other axis you might think about would be, how exactly do you manage the memory transfers and the communication? Do you do it again with instructions and make it very flexible, or do you do it completely in hardware, right? And so the way I like to think about data flow is that data flow gets you into the sweet spot, especially reconfigurable data flow, in that it does allow you to be flexible, but it allows you to be flexible on the time scales that make sense for AI models, right? Which means that you're not changing things every a cycle, right? You basically fix the model for the time at which you kind of are doing the inference. And when another prompt comes along, you may go to another model, but typically not. Actually, you're going to fix that model on the machine for a while. So you don't have to make it completely flexible, but you should make it so that you can change the model and optimize for the model. And so reconfigurability gives you that capability. Okay, so data flow. So let's talk about the memory access, right? And so you think about the size of the models, you need trillions of parameters, right? And so if you just limit yourself to the memory you can fit on on the chip or on the wafer, then you're kind of limited to maybe 40 or 50. If you're just a single chip, maybe half a gigabyte. You think about a wafer, maybe 40 to 50 gigabytes. But if you need enough memory for a trillion parameter model, that's a lot of on-chip memory, right? Now, so what you want really is to put the model in HBM, but make sure that you use that HBM as effectively as possible. And the way that you do that is by using hardware mechanisms for moving the data from the memory to the chip and between the compute chips, right? And so the idea is, how can you be completely flexible, but with very, very low overhead, almost no overhead, right? And so the problem with GPUs is they do use HBM, so they can run large models, but they synchronize the data movement and the movement of communication of data between chips all in software, right? And that adds overhead. And it means that in particular, that they have a lot of trouble overlapping computation and communication. And that is in fact the key, right? So what you want to do is you want to communicate, but you don't want to communicate by waiting until you need to communicate, and then you have to run instructions to move the data. What you want is to construct a pipeline in which the communication is just one component of the pipeline. And so the way to think about this data flow execution is that communication is happening all the time, and it's just one of the pipeline stages. And communication is happening for the last piece of computation, a piece of the computation for the model, while the computation for this piece of the model is happening in some other stage in the pipeline, right? So it's a classic idea from computer architecture, pipelining and the use of a memory hierarchy to move the data when you need it to where you need it at the right time. And so the nice thing about these AI models is that you do have a graph of computation. And the whole idea of data flow is to take that graph of computation and map it onto the machine in a spatial way such that you keep all the pieces of the model operating at the same time on different components of the computation that needs to be done.
Can you contextualize a little bit? Let's say you have a Llama 3 model and you have a, let's say, normal, like, NVIDIA H100 or, B200 chip versus a, RDU chip. What is the difference in the amount of HBM required? Like, is there a sense of, like, you would say, like, okay,
So it's not really a capacity question. It's really a bandwidth question, right? So the two ways that the GPU uses bandwidth in ways that are not optimized. One way is that they divide the decode algorithm that you, in order to decode for a single token, you've got multiple steps of the decoder, right? So take one step of the decoder, right, and think about all the kernels that have to execute in order to execute that decode step. Well, the way that the GPU typically does it is they execute the decode algorithm one kernel at a time, right? So there are some big kernels like flash attention, right, that have been optimized. But in general, there are multiple kernels that have to execute. And there are two overheads that happen. One is you have to move data from the GPU, from from one kernel to the HBM, and then the next kernel has to go fetch that data back into the GPU. That's wasted HBM bandwidth.
Right.
Okay. The other aspect is you spend time launching that kernel and synchronizing between the two kernels. That is time that the HBM is not actively being used, right? So you have both wasting of bandwidth when you don't, when you shouldn't waste it, and you have time that you're not fully utilizing the HBM. Okay. So the way that things work on a RDU in a data flow map is essentially you take the decoder and you make that a single kernel, right? And then you go even further and you use a technique that we've developed called kernel looping, where it's because you've got a single kernel and you need now, if for instance, if you're thinking about Llama 370B, you have to run that decoder 32 times. Well, you keep that single kernel decoder on the array of chips at the same time, and then you just keep looping, right? And so the net result is you keep the HBM completely occupied,
right,
and you don't ever send any intermediate data between the kernels across the GPU or the RDU HBM boundary, right? So you have both a more efficient use of the HBM bandwidth, and you have a more complete use of it, of the bandwidth. But we're not done there yet, because the key innovation, and I kind of alluded to it earlier, is that you've just, because you're running across multiple chips and you're using what we call tensor level parallelism, right? So at some point, you now need to gather all those results together, right, in an all reduce. That's communication, right? You don't want to have that communication be a thing that limits, that stops the pipeline, right? So what we're able to do is we're able to communicate from one RDU chip's SRAM to another RDU chip's SRAM without going through HBM. This is called, we terminate the communication inside the SRAM, right? So we don't use HBM bandwidth. And more importantly, it means that we could just treat the communication as another pipeline stage that we overlap with all the other kernel components of the decode algorithm, right? And so we get this more effective use of the HBM bandwidth. We keep the HBM running, we keep the HBM utilized all the time, and we go back to that metric that we talked about, memory bandwidth utilization, right? This is how we push it as close as possible to one, right? Because we make sure that we only move the data that we absolutely have to move from HBM, the KB cache, and the parameters of the model, and we make sure that interface is used as close to 100% of the time as possible. So those are kind of the key ideas, and back to this question, sort of why can we do this extreme fusion into a single kernel? It's because we have more SRAM on the chip, right? So you can say you put more SRAM, and then you can say, well, I'll put everything on the SRAM, both the intermediate data between the kernels, and also I will put the KV cache and the parameters. But then if you only use SRAM, then you get into a very expensive system right?
Mhm.
And so the key idea then is let's build a system that is scalable. So especially with our latest version, the SN50, you could scale it all the way to 32,000 chips if necessary. So in scale out, in scale up, we can go to hundreds of chips, and then you can get the ability to run these large models very cost effectively, but you also make sure that you can get this very high speed decode capability by using the data flow ideas to make sure that you can not spend time so that you can effectively use the tensor parallelism, right? So one of the limits of GPUs is because they don't effectively overlap communication and computation, they have a hard time using tensor parallelism beyond 4 or 8, and we can go to much wider levels, which means that we can get higher speed token generation.
This has been fantastic.
So back to your question, Nathan. So
Please.
If you kind of think about where the different architectures sit, right? I would say that the GPUs are sort of in terms of their flexibility, they're highly flexible. They're instruction driven. They are their overheads are such that they have. They're limited by the fact that they do have this instruction overhead, but they do have the advantage to take advantage of the HBM capacity to be able to run very large models, right? If you're thinking about Grok and Cerebrus, they are SRAM based, and so they can't very cost effectively handle very large models. And in fact, if you get to the trillion parameter size, then it's unclear how you can gang enough systems together to handle models of that size. And then, of course, they might claim that they're data flow, but I would say that they're not quite data flow because they do involve instruction overhead in synchronization and orchestration, right? And the key to data flow is to hide all of the overheads of the communication by putting that synchronization and orchestration in the hardware. And so that's what we do on the RDU design from SambaNova.
We're at the time that we had booked. Do you have time for a couple more questions?
Yeah, sure.
Could you talk maybe a little bit then about what bullets you have to bite? You kind of alluded to at least one on the not targeting the training market side. Curious if there's any other, big bullets that you're biting with this architecture. And then I'm also curious about how this kind of translates to Pareto frontiers for your customers. Like we see now the emergence of fast mode, right? And there's clearly this trade-off between speed of return and batch processing, which, batch size, which obviously translates to cost. So could you maybe characterize how your Pareto curve that you offer to customers compares to other Pareto frontiers in terms of volume versus speed type trade-offs? And then translate for me how that, what kind of customer is like the sweet spot customer for you? Is it somebody who needs more of one, more of the other, versus, the kind of hardware that we're more familiar with?
Can you say that last bit just again?
Yeah. So, with the idea in mind that there are these trade-offs and probably the trade-offs with a SambaNova system are different from other, available systems one could buy. What does that translate to in terms of the most natural customers for you?
Yeah, that's a really good question. So, everybody's seen the Pareto curve that Jensen put up, the trade-off between throughput on the y-axis and speed per user on the x-axis. And what we see is that we don't in sort of previous generation like SN40, we could get the same throughput as a GPU at 3 to 5x higher speed, right? On the SN50, we don't have quite as much compute. So, as you go to very, very large batch sizes, the GPUs do very well. But once you get over 250 into the 500 tokens per second per user, this is where we can get, again, we can achieve those speeds at throughputs which are 3 to 5x better than what the GPU can provide. And so if you're thinking about, a frontier lab or a neo cloud that wants to provide premium tokens, especially in the neo cloud on open source models, this is a sweet spot, right? So if you think about a Minimax coding model, for example, right, where if you kind of go to our service, you can get speeds of 5 to 10 x faster on Minimax 2.7 compared to what you can get from other providers, and that's because it's being powered by our SN40 capability, which is our previous generation. And 50 provides even more capabilities because it has the ability to scale to much larger number of chips using the techniques that I just described. And so, get back to this premium token idea. I mean, that is the ideal customer for us, somebody who wants to provide premium tokens to their users. Another good use of our system is something that we announced at Computech a few weeks ago, and that was the idea that you could gang up a RDU system with a GPU system in a disaggregated manner, right? So the idea is that because GPUs have more compute capability, they're better at prefill, and RDUs are much better at decode, which of course is the ultimate limit. And so you could do the prefill on a GPU, you could use your existing systems that you have in the data center, and then you could bring in RDUs at some ratio, 1-to-1 or 2 GPUs to 1, to enable you to get very fast decode capability.
So one of the questions I had for you is, we had a guest, Bing Zhu, on the show before, and they were doing PTX instruction kind of optimization models.
It might be, maybe Mark.
They were doing PTX instruction models.
We can hear you.
Hearing. Are you hearing me?
Yes, we can hear you fine. If you switch from like earpods to like computer mic and then back, it'll refresh. So we can hear you fine.
I'm not hearing.
So maybe just refresh. Just press refresh on the page. Oh, he can't hear us. I see. We gotta drop off. Oh well.
Never a dull moment in the live streaming game.
Yeah, it's doing it live always has a more risk. All right, we'll see if we can, or we'll just message. I think so. sudden drop off. Let's see.
I don't know if we do have Brian here as well in the background. Brian, if you can hear us, maybe send a ping for just a quick page refresh. I think would be all we need. I sent that via email too.
Notes for improvement. Room for improvement here.
This is the. Shouldn't the banners, attention, whatever API is filling in the headlines on the screen, send a signal to Greenlight to have him refresh the page? Let's see if that works. Prompt injecting our headline writer. I could also come back. He might hear me if I come back. That'd be another possible switch. All right, let me refresh as well, and then maybe he'll also get the hint if I refresh.
Yeah.
All right, I'm back. Can you hear me now?
He saw the refresh, I think. So maybe if once he comes back, we'll do a quick roundup, and we'll let him go. We stretch this time a little bit. So it's the whole architecture question is fascinating, because it indicates that there are ways around the NVIDIA monopoly, and people are working hard on them. So one does hope that we can. There we go.
I'm not sure what happened there. I'm sorry.
We are for sure our fault.
Yeah. Sometimes it's our fault. Sometimes it's LiveKit's fault. Like I get emails from the dev team like, oh, we had an outage. I'm like, you should have told us that before.
Yeah. Okay.
But we're back.
We're back.
Okay.
We'll just kind of round up, like, what have you seen in terms of using AI within the design process, as in within your firm, in order to build software, build better tools to get around this whole CUDA moat idea, and where do you see things? And the second question, kind of what is your, like, what does the roadmap look like on a 3 to 5 year mark for the firm?
Yeah, well, I mean, I think this is something that I'm interested in both within SambaNova and is a big component of my research at Stanford. Sort of how do you use AI tools to speed up the design process, right? And so, of course, like every other firm, we are actively using AI, both open source AI models and Frontier Labs models in conjunction, because of course you want to control token cost, right? And so we've got models that run very efficiently on our machines, and so we combine them for tasks that the open source models can handle. And we then, for the very challenging tasks, of course, we'll go to the frontier models in order to take advantage of those capabilities. So yeah, that's getting used throughout the firm for all sorts of software development. We never, of course, use CUDA in all of our software stack, and we never thought CUDA was the right way to think about designing these compilers. And so we started, with the PyTorch representation of the data flow in the AI model. And our whole goal was to take that representation and map it to our machine in a data flow way, right? And so that kind of completely sidesteps CUDA. And then from the point of view of developers, what we wanted them to do was to be able to describe the way that they wanted to optimize their model at the PyTorch level, right? And so the way to think about parallelism in these models is that it happens in multiple dimensions, and you should be able to describe those dimensions, whether it be tensor, or there'll be data parallel, well, it'll be pipeline parallel, and you can describe these kinds of optimizations at the PyTorch level, and then our compiler can take those directives and do the appropriate mapping. And so, remove the need for the user to write low-level code like CUDA, but still achieve the performance levels and the mapping control that they really need to get high performance. So your other question was, where do I see the company going in 3 to 5 years?
Yes.
Is that?
Yeah.
Yeah. So we will continue to push on. In 7 years we've taped out 5 or 6 chips, right? So we're on this cadence for every 18 months or so. We tape out a new chip in the year to 18 months, and so we continue to push on our ability to provide premium token inference, right? Which means focusing on, more bandwidth. Traditionally we've been one generation behind where NVIDIA has been in terms of both technology, but definitely HBM technology, right? So our current designs are using 2E, and we're able to kind of compete with 3E from NVIDIA. But we want to continue to make sure that we use higher performance, more recent HBM. We want to take advantage of the new ideas around packaging, 3D packaging and chiplets. We will think very deeply about how we design the next generation of architecture to both take advantage of the memory bandwidth capabilities of new generations of memory, and also the ability to both scale out and up, right? And so we want to make sure that we can get very, very fast inference on very, very large models, and that will be the key to that will be exploiting parallelism, especially the kind of parallelism that requires that we have this communication between multiple RDUs. And so figuring out how to make sure that we can do that without the communication between chips getting in the way is going to be the key challenge. And so we've got all kinds of interesting ideas about how you do that, right? And so, we want to be the highest performance and lowest cost inference provider, in terms of the capabilities that we provide from the RDU technology with the SN50, which we have announced, the SN60, which will be coming down the pike soon, and of course, future generations of our product will also be focusing on the same thing. We want to make sure that we maintain that flexibility because, I see the landscape of AI models continue to change, right? And there will be new varieties of transformers. There will be state space models. There will be ways that we fundamentally have to transform the algorithms in order to make them more linear, because we can't continue to go in this quadratic direction if we want to really enable everybody to use AI in a cost-effective manner.
Mm-hmm.
This has been fantastic, and I really appreciate you staying a little long with us. If I can dare to ask just one more question.
And I'm sorry, I can't hear a word Nathan's saying.
Can't hear me again? Oh my God.
gosh,
Prakash, can you hear me? All right.
I can hear you.
All
Kunle,
right,
can you hear me?
You can.
Okay.
Can you not hear Prakash either? So bizarre.
So bizarre. All right. So, all right. Let me switch this.
Note to our agents as they go through the transcript, we need a like refresh button in our producer view to just refresh somebody's. Thank you for joining us. Sorry for the technical difficulty, but this has been great. Well, that was a little rough. The last question I wanted to ask was just around, let's say they achieve all their goals in terms of design. What will be the barriers to scale up? And maybe we can, send him an email and get a little extra thought on this and share it back. But in previous rounds of kind of going down the what is NVIDIA's moat rabbit hole, one candidate answer has been at times conviction, balance sheet, and lockup of the supply chain. That they are just willing and able to buy out capacity from key suppliers for years to come. And I don't know, I've heard that for a while, but we've seen that there's at least enough slack in the market for, decabillion-dollar companies to pop up. And it seems like, as you mentioned in the intro, SambaNova is trying to be the next Deca unicorn in the space. So what's happening there? Have the suppliers sort of said, we're going to cap what NVIDIA can buy, so we're not, don't sort of lock ourselves into a monopsony future? Have they, are there clauses that allow for flexibility? How is it happening, that somebody can come into this supposedly, and I think not just supposedly, but, this super input constrained, super complicated supply chain, and buy their way into being able to ship finished product in the, on a time scale that matters? I don't have a great sense for that. So
I kind of have a sense for what's happening right now. So number one, SambaNova chairman is Lip-Bu Tan at Intel. And so they're definitely going to use the Intel foundry. And the Intel foundry doesn't have enough customers, right? Like Lip-Bu has been signing with Apple and signing with other people and trying to get them to use the Intel packaging and Intel chip manufacturing fabs. So I think SambaNova will clearly, Intel has also put in an investment in them. So clearly, I think they're going to become, they're going to tape and they're going to produce at Intel. I think that's clear. On the other question for NVIDIA, and for number one for NVIDIA, I think Jensen is always under antitrust eyes now. And he's got all of these very powerful hyperscalers around him, being very annoyed with his pricing. So he's got to be aware of this. And he is making deals. He signed a deal with Corning, glass manufacturer for optics, this week. And he is co-building a factory with them. So he's put in, I think he's putting 40 or 50%. They're putting in, and then they'll put in the expertise, and basically he'll buy the product. So he's building out factories, and that's a little bit hard to say that it's an antitrust issue, because the factory wouldn't exist if he hadn't put the money in. It's not him buying out capacity that already exists. It's creating capacity that didn't exist in the market. So I think that's hard for an antitrust case, and I think they're aware, and so they're targeting these things where they can start to own pieces of the supply chain directly. That's one. For the smaller chip startups, what ends up happening is that Broadcom or some of the larger guys have allocated capacity for wafers at TSMC. So what ends up happening is these guys, the smaller guys, end up going to Broadcom And Broadcom takes a vig on on that, and then they basically manufacture through Broadcom's relationship at TSMC. Qualcomm also has some capacity allocated, and so Qualcomm also can swing a little bit. So these guys have like some allocated swing capacity in the industry that the smaller guys can use if they pay for it, right? So this is what has happened roughly in the past like 12 months or so. And it's not really that you can't get capacity, it's that you're going to have to go through people who have the capacity already, and you're going to have to do deals with them in order to make it work. So
nice, great answer.
Yeah. So, I finally kind of understood what the new paradigm is. So I get and correct me if I'm wrong, but basically what he said is that a normal GPU acts a little bit like a hub and spoke system. And for every step of the decode process, it goes back to the hub and then goes back to the spoke for processing and then comes back. While for these new chips, like the SambaNova, they're acting like a conveyor belt, where it goes to the first one and the second one and the third one and the fourth one, which is what it's supposed to do anyway, because that is the steps that it's supposed to follow. And that's already defined. And so basically that's what they're doing. And this is the difference between the GPU paradigm and this paradigm. Is that roughly what was going on?
Yeah, I think that aligns with my understanding. I mean, I'm always, in general in AI, when people make comparisons between their technique and some baseline, I'm always a little wary, depending on how well I understand that baseline versus like what's actually running, in optimized form in production. I'm always like, okay, yeah, that sounds right. Are they actually doing it that way, or do they have some other, workaround or optimization that narrows that gap somewhat relative to, the kind of default or like naive path? And we've seen this with sort of transformers a million times, where people will be like, oh, my new architecture outperforms the transformer, but it's like, well, what transformer, right? And if you're using the 2017 initial transformer as reference, like you're obviously way underselling what it is today in fully optimized form. So I'm always a little wary of that kind of thing, at all levels of the stack. Mm-hmm. But I think that what you're saying there adds up. And then there was also this other big concept of blocking versus non-blocking. Yeah. And I don't quite understand that as deeply as I'd like to either, especially when it comes to how hard is it for NVIDIA to get out of that problem? Is there a reason that is sacred in their architecture, or is there an opportunity for them to relax an assumption or two and, get to where SambaNova is on that dimension with the next generation? I would be speculating definitely out of my wheelhouse and out of my depth to say much more than that. But yeah, like what bullets would NVIDIA have to bite to not have these blocking issues? Unclear. So
let me give you like a kind of industry structure kind of thing, right? Maybe if you have like NVIDIA chips are good for frontier because the GPUs are eminently reprogrammable and you can run like multiple architectures on them and you can develop these new architectures on them. So what ends up happening is that if the frontier advances quickly, then the GPUs get utilized. If the frontier advances slowly, people start to optimize on the inference quickly. So you have, again, this kind of two waves of, on the one side, the frontier advancing. If the frontier is advancing fast, people need to be at the frontier, and there's not enough time to optimize the inference. But as the frontier advances, and 6 months or 9 months or 12 months behind that frontier, you have the inference optimization wave, which is following up. So the frontier chips first get used for the frontier, and then they kind of fall into the inference. So for inference, the GPUs are imperfect, but they're also depreciated because they were used for the frontier, and now they can be used for inference. So that's why the H100s are still being run for inference, for example, because you no longer develop the leading edge frontier models on those chips anymore, but they're good enough for inference. And so that's what ends up happening. You have this kind of two waves, and it's kind of similar to the two waves that we see in the model labs versus open source. Again, you have this, the leading edge, which is creating the new stuff. And again, you have this kind of optimization and like distillation, consolidation wave, which is following up and which is reducing cost. So you have these like multiple waves proceeding through the industry at multiple layers simultaneously. Does that kind of make sense?
Yeah, I mean, he did specifically note too that they've historically been one generation behind NVIDIA, and so that definitely reinforces that notion. We also heard from SpaceX AI that a similar thing, right? They were willing to rent Colossus 1 to Anthropic, probably because they didn't have a lot of inference load themselves, but also the idea was it was sort of a mixed chip environment, and it was becoming problematic for the training. And so the Colossus 2, which is like a more homogeneous environment, just a better place to train. And, thus they didn't really need the first one as badly anymore. They didn't feel like they were sacrificing their frontier work to rent out what had kind of become now more of an inference capacity facility. So yeah, I'm trying to think of what the complications of that would be, or if there's a counter to it, but all the data points that are coming to mind so far support the general paradigm that you're laying out there.
I think like the chip business in general is just going to get so much bigger. I think there's enough food for everyone, right? Like the entire business is going to get so much bigger because you're going to get all of these like different niches where all of these different players can thrive. So it's really a swing. It's like a swing back to like mid 90s, kind of like the chip era again. So
yeah, all compute is food for these AIs. That was the title and a song lyric from an episode of the podcast I did with Jeffrey Laddish from Palisade. And I've got one coming up with Ramin, the CEO of Liquid AI too. And I'm just thinking a little more about how even small bits of compute, are starting to become relevant. The cell phone market is $500 billion a year. Like, it's been at the scale of the data center build out for quite a while now. The data center build out is now surpassed it in terms of annual scale, I think, but not that hasn't been long. So I do think we're going to see kind of, it always comes back to everything, everywhere, all at once, because we pretty soon. I think this is also, as I look back and think about my predictions that I got wrong. I think one big one that I sort of got wrong was that inference will be really cheap. There was a time, in a way I'm still right. It depends on how you want to look at it. But it's definitely not as cheap as I thought. It doesn't feel like it's like super abundant, to the point where it's not too cheap to meter, right? Like, we have not hit that level. And I don't know if I was expecting too cheap to meter, but I was definitely expecting closer than where we are right now. The way in which I was right is that Fable is still cheaper than the original GPT-3. It was $60 per million input tokens, 60 per million output tokens, no caching, twice as much if you did fine tuning, and obviously, dramatically less capable in all regards. I think the thing that I underestimated probably was just how many tokens more a frontier model would use. We were putting in a couple thousand at a time to GPT-3, and we were like, oh my God, this is 15 cents, to make this one API call. And that felt like a crazy thing when in general API calls were, in any other kind of API were like 1/10 of a cent or less. But then we saw, dramatic cost reductions with 3.5 and Turbo and all those kind of, models dropped those costs by almost 2 orders of magnitude. It was like 98% cost reduction with performance improvement. And at that point, it wasn't so much token hunger. Now we see this incredible token hunger. I still think that there's an interesting question. I mean, another thing that's really changed is we've moved to a world where we're now in the market clearing price era, as opposed to the labs trying to use up, trying to create the market out of nowhere and like get the whole thing going era. So now we're at a place where you could run things for a lot less, but it's just not available because the market for the chips continues to push prices up, as we've discussed many times, even on old chips. So I think I underestimated token hunger, and I underestimated demand just bidding up compute regardless of all other progress. Even still, it's like cost per million is down, which isn't, amazing. But we're in a metered world, that's for sure.
I suspect the metered world is temporary, because I think what ends up happening is people have budgets and the firms have to capture like wallet share basically. And so the wallet share, like the whole sticker shock thing, I think doesn't work. They either have to like pay for performance in the sense like, okay, you get a new cancer drug, you get paid for that, right? Like that is something that is like measurable, like return on investment. Or you're a cost. You're not a revenue item, you're a cost item. So then it becomes like, okay, this is how much I can afford. I will buy all of the most intelligent stuff that I can get within this budget, right? So, and I think that is what is happening right now. It's this reconfiguring of the market to, we had this first expansion. We had this, the blow up earlier this year. And now this is reconfiguring to like, okay, this is my wallet share. What can I get with this wallet share? And like with this wallet share, what can I do with it, right? The one thing that I think the X factor here, which I don't know how it's going to work out, is whether or not these models become so much more intelligent like this year that you again get this like expansion of like budgets. Like we got to have it, everyone has to spend tokens. This is the most important thing, which is basically what we had earlier this year. Do we get another capability step up where that kind of thing happens, you think?
Yeah, I'd bet on one more this year. The first kind of hinge point was probably whatever people date it to, like Opus 4.5 to 4.7, somewhere in there.
Yeah.
The second one is Fable. Fable was done training early this year. It took us a while to get it. We obviously have had drama around it, but it's hard to imagine that there's not a significantly better step coming in the second half of the year, and maybe two. That if you listen to the people closest to it, and it has always served me well to take their statements both publicly, kind of reading between the lines, and any private statements where I'm not told secrets, but I'm given general direction as to what they are expecting. It's always served me well to take that at pretty much face value. And what I think the signal is from the folks at the frontier companies is things are speeding up. They're not slowing down. And we're entering the era of recursive self-improvement. There's probably still a lot of low-hanging fruit in all kinds of different levels of the stack. And so, yeah, we probably should expect at least one more significant turn within the calendar year. I'd be very surprised. I mean, it would be the first time in many orders of magnitude of inputs that we wouldn't get another significant step on that timescale if we were to not see one the rest of this year. So I would have to imagine that it really is coming. And certainly they're building out with the conviction, and they're doing everything they can to secure capacity with the conviction that something like that is coming, and that the exponential of demand for their products will continue, or super exponential potentially even.
Yeah. It's they do have to like start providing like significant value. That's the thing, right? Like the first step, the coding. Okay, yes. Now everyone has like software coders on standby, like infinite software coders. Okay, great. But like a Nike, for example, like, okay, so now your team is using tokens. Like, what else can you do for me, right? Like, how else can you increase my revenue, or how else, cutting cost is not that significant. Like American firms rarely like focus on cutting costs that dramatically, except if it's a downturn. And if it's a downturn, they have like a stash of like employees that they're prepared to let go, and which are which already been pre-identified kind of, and they're like, all right, let's let go. So I think like the key thing that makes people buy something is revenue increase. How do these models increase Nike's revenue, right? Like they have to do something for the marketing, or make people buy more shoes, right? Like, how does that work, right? That I don't know. Like I can see it for coding, but for Nike, like how do you get Nike to like allocate its IT budget almost exclusively to you, right? That's still.
Yeah, I mean, how elastic is demand for shoes? I'm not super sure. I personally am making progress on my 2026 goal of spending more time outside, getting more exercise. I think there probably is like an extra pair of shoes in 2026 for me as a result of my, increased pounding the pavement as I'm liberated from my desk via AI. So, that's one happy story. My guess is that doesn't move the aggregate shoe demand, in the immediate term. So I would say it probably is tough for a business like that immediately. But, then I think about I just did this episode, came out yesterday, with Thomas von Chalmer, who runs the US division of this company called Neural Concept. And they may provide some inspiration for how you could imagine a company like Nike taking their business to the next level. So basically what they do is, traditionally, they provide models that validate designs, engineering designs, like CAD designs, on a variety of dimensions. One big one being aerodynamics. So and they actually work with like Formula One teams, which I didn't realize. I've never been a Formula One head, but they actually have rules around how much compute teams can use from week to week to optimize their design for aerodynamics and I don't know, whatever else. But you're literally compute limited as an F1 team. And if I understood correctly, there's also like a handicapping where like the best teams actually have lower compute limits than teams that are not doing as well. So that's fascinating unto itself. They have Formula One customers. They also have, just major automotive manufacturers, and their kind of break into the market point was these models that allowed you to run validation of things like aerodynamics or heat dissipation or whatever much faster than the physics-based simulations would allow, and thus you could more deeply explore the design space and get your designs more optimized before you ever have to make a prototype, et cetera, et cetera. Now they are also bringing a agent to market at the same time. So now you can have a neural concept agent that actually works in your CAD platform in a similar way to your human engineers, and can, call out to these models and say, hey, I just made a tweak, validate me, with the aerodynamic model or whatever, give me that feedback. And they can kind of run this tick-tock loop of agentic exploration, validation, optimization, which is the perfect formula, obviously, for reinforcement learning. Is definitely going to allow, to the degree that they want to, take a hand in training models, it's going to allow their agents to get quite good at climbing these hills. We should, of course, expect, I actually think Grok is a good candidate to get really good at that kind of thing.
I always thought Elon should just focus on that. They have so much,
he's so distracted by various kinds of porn and whatever. It's
they have so much internal data which no one else has on airflow and material science and all of this stuff. And he ends up focusing on LLMs and Grok Imagine and whatever. What are you doing? Google doesn't, Demis would love to have all the aerodynamic data and all the data on that stuff, right? You would love to have it. And they have a team that can do experiments too. So you can have you can set up what Periodic Labs has done, and you can set up a robotic experimentation lab, and you can get a hit on material science and all of these things. And he ends up in LLMs, back in LLMs. And so that's a little bit disappointing, I think. So
yeah, I wouldn't count him out just yet, right? I mean, never bet against Elon has always served me pretty well too. I mean, to land the plane on the Nike analogy, I guess if you can get that loop closed, right, and you can get this sort of agentic model making these design tweaks, getting validated, getting really good at climbing that hill, that's a pattern that basically works for everything. I would bet that Nike clearly they have some way to forecast demand for products. Does that extend to the point where they have a sort of black box ML model that takes in just a design of a shoe and predicts how popular that will be? Maybe, maybe not. It would be interesting to see if we can get an answer to that question. If they do have that, then you can imagine them having an agent that actually does the shoe design, and kind of close that loop again. And so how can they drive more revenue? I mean, one big answer, which they're already quite good at, but you could imagine another order of magnitude would just be infinite designs, right? Extreme, even more extreme, long tail, and personalization even. And if that becomes a token budgeted process as opposed to a human shoe designer process, then, if we're all rich and enjoying abundance in general, then maybe we buy 2 times as many shoes along with a bigger basket of everything else. But maybe they can only realize that if they can really scale that design and validation loop to the point where, I can get something that, nobody's ever seen before. And you can too.
Which is an RL loop, right? Which is a reinforcement learning loop at the end of the day, right? It's a reinforcement learning loop with the human input for taste, right?
Yeah. So, I mean, Nike does seem, I think you're right to say Nike seems like one that is relatively mature, not as likely to be able to, see massive growth as a result of AI as some other things might. But still, we can tell a story.
Basketball shoes were not a big thing in the 1970s, right? It was really post Michael Jordan, late 80s ish when Michael Jordan signed with Nike, and then it kind of took off. So you could kind of see maybe Nike gets a marketing proposal of that kind for some other segment, like, maybe old people's shoes, maybe or the orthotics, whatever, right? Some other segment of the market, and all of a sudden that segment also becomes this kind of place where you can take like $5 of plastic and sell it for $100-$200, right? So maybe that's the thing. Maybe that's the thing that happens. Who knows?
All the senior living communities are going to be on fleek with the shoes, perhaps. Do we still say on fleek? I don't know. That one, I don't know where that came from. That's a deep cut. But yeah, we'll know if my mamaw's wearing multicolored custom designs in the next 12 months. We'll know how it happened.
Yeah, indeed. And on that note, Nathan, good morning. So it is 2 days before America's 250th anniversary.
Amazing. How about that?
And so happy birthday to the Republic. And we will see viewers and listeners next week.
Here's to virtuous leadership long into the future.
Indeed. Bye-bye.
Thanks, Prakash. Bye for now.